We've all been following the evolution of graphene for years now, or ever since it came into light with the 2010 Nobel Prize. But graphene has been around for longer than that, or at least 63 years in the making. 9 years after graphene took over the world by storm, many of us are still wondering about where are all the things that we were promised, made with graphene. It all started with a block of graphite back in 2004 when two scientists, Nanene and Konstantin Novoselov at the University of Manchester, managed to produce something that was in the works for the past 14 years. Since 1990, scientists were trying to come up with different methods to isolate graphene from graphite, but for all that time, all they managed to get was nothing thinner than 50 to 100 layers. However, this is only part of the story, as the single-layered sheet was first theorized back in 1947 by P.R. Wallace as an attempt to understand the electronic properties of 3D graphite. 63 years later, and it became a hit. Suddenly, everyone was talking about the wonder material that would make computer chips thousands of times faster, of an atom-thick sheet that could hold a baby, impenetrable armor, batteries that could hold hundreds of times the current energy density, and you name it. But suddenly, everything just sort of stopped. Since 2010, graphene has been on the news, but not as much as it used to. Partially because the hype slowed down after peaking in 2014. Not that it went away, but the news, even though are promising, something is still missing. There are many reasons as to why this happened, but the main one comes down to one simple fact. That one magical product that we've been waiting for is just not here yet. That is because of one big problem. Scaling up graphene production has been the challenge for the past 9 years or so. There were many proposed ways to produce it, but unfortunately, they all fail at the same point. You see, the one major problem that researchers are facing is on how to make a large enough sheet that is free of defects. Especially if you want to make electronic components. In this case, you have to make sure that the sheet is free of defects, or else it won't behave the magical way that we expect. And because of this, the race to find ways for mass production is a closely held secret, even for universities like MIT, because ultimately we are talking about easily $1 billion if not $1 trillion industry based in a single material. So we should expect that the race to find bigger and better solutions for massive production to be a fierce one. Now, scaling up the production is by far the biggest problem holding back the adoption of graphene, since quantity is very limited and quality is questionable. But another big issue that researchers face with mass production is the misaligned crystal structure of the graphene sheets. This pattern that you see here fundamentally changes the properties of graphene, yielding a less efficient product. You see, for you to get all of the magical properties of graphene, you have to have one continuous and uninterrupted sheet. Currently, this is the challenge for electronic components and structural strengthening. For structural strengthening, these misalignments make it easier for the sheet to break or rip with enough stress. As for electronics, it makes it harder for you to create band gaps so it can be switched off. But we should remember that the silicon industry went through the same problem when they first started using it to make computer components. And just like they had refinement and purity issues, graphene is going through the same path. The only difference is that we now have a lot more developed technologies that can help speed up the research. Nevertheless, everyone is still waiting for that one product that will revolutionize everything. For instance, everything would change in a matter of seconds if Intel or AMD created a graphene chip that is 1,000 times faster than the current generation. But we are still at least 5 years away from this technology, so I guess we'll have to wait. Also, you have to keep in mind of how disruptive this would be. If any of these companies created this magic chip, many of the gadgets that we use today would see a sharp decline in price because graphene eventually will become much cheaper. That is not good for business unless you are the startup that developed the technology, to which most likely you would be bought by the big company anyway. Regardless, the introduction of anything this disruptive has to be slow. Exactly what we are seeing right now. In spite of that, some companies are innovating, and although their products aren't magical, graphene is starting to take over some industries, slowly, as we'll see next. There are three main immediate applications: as a thermal insulator, nanocoating, and structural strengthening. These three properties have been tried with other materials for many years, but it is the first time that a single one can do all three of them at such a high level and versatility. But like plastic, which went through many decades of research and development, since the first polymers were invented in 1869 and the first fully synthetic plastic created in 1907, it was the Second World War that triggered the necessity of plastics and jump-started the industry as a whole. Nowadays, it is believed that the private space race will most likely be the booster for the development of graphene technologies. But fortunately for us, the sports industry is already using in its equipment, and some of the products are already available for you to buy. On a side note, as a curiosity, and you probably didn't know this, but graphene was actually used in the Winter Olympics of 2018 in the skeleton modality. For those of you that don't know, it is the one sport where the guy runs and with a small sled and then dives on it, rushing through the frozen track at high speeds. Fascinating to say the least. In this case, they used what they called Nanene, which is not really a single sheet of, but more likely a powdery graphene nanoplatelete, which would fall more into the carbon fiber polymer, to be honest. The difference here is that Nanene is only 10 layers thick, but even then you can still enjoy the strengthening properties of graphene. If you're curious, it was used by the British medalist Dominic Parsons, which won the bronze medal. The concept here, and as we'll see more later, is that graphene can be used to strengthen any structure, making it lighter and stronger. For further reading, you can head to the Nanene website where they have all of the information you need. Head, the tennis racket company, has a range of graphene composite rackets available since 2013. This company is actually one of the first to adopt graphene in its products, and the one that stands out is the UTech Graphene Speed Series tennis racket in their skis for women. The system here is similar to the Nanene, or in this case, it is speculated that they used what they call the AGM graphene flakes. Applied Graphene Materials, aka AGM, is a company that is specialized in graphene solutions for commercial applications. On their website, they have a wide range of products like graphene nanoplatelets, paint and coating, polymer and composites, thermal paste, lubricants, and energy storage. All of this is done with graphene nanoplatelets, which again is not a single sheet, but it gets the job done. Moving on, we have one of the best examples of what can we expect for the future of spaceships. Although this next example is not even close to one, the use of graphene highlights its potential as a structure strengthening material. Decibike is a company based in the UK which claims to have created the first graphene bike frame, although it only contains 1% of it. But make no mistake, although it looks like an insignificant amount, this is enough to help the structure in many ways. And in this case, they achieved a frame weight of about 750 grams without paint, which is not too far from other brands. However, engineers believe that graphene would make it possible to produce frames that can weigh less than 400 grams. To achieve this, they applied graphene nanoplatelets suspended in an epoxy in between the layers of carbon fiber. This method increased the strength of about 70%, or it's almost double the strength of the frame. And the cost of the frame is about $8,500 USD. And let us not forget the tires. Vittoria is a bicycle tire manufacturing company that is based in Italy and recently developed a graphene layer filler for its tires, which not only increases puncture resistance, but also wet grip and durability. The sports industry is not the only one benefiting here. Due to its thermal insulation and dissipation properties, some companies are already using it in their electronic components. Due to its excellent thermal conductivity property, graphene is by far the best candidate to be used as a heat dissipation in passive or active cooling. A company specialized in computer components called Team Group made available recently one of the first computer solid-state drives for their gaming line products called T-Force, or the T-Force Cardea Zero M.2 PCIe SSD with a graphene copper foil cooling that increased heat dissipation by 8%, increasing performance overall. And other electronics can also benefit from graphene, which is the case of earphones. Here, due to how thin you can make graphene, it can be used in their drive membrane or diaphragm. A diaphragm is the thin, semi-rigid membrane attached to the voice coil, which moves in a magnetic gap, vibrating the diaphragm and producing sound. The diaphragm are usually made out of silicone or polyurethane. Graphene is used here as a layer material to enhance its performance by making it more lightweight, which in turn improves sound sharpness and reduces high-frequency bands, giving a better sound experience overall. This is yet another example of graphene being used as a structural enhancer. There are mainly two products being sold at the moment of the making of this video, where one is from a Chinese-based company called FIIO Electronics that currently ships to US and Canada. Anker, another Chinese-based company, has also made available its graphene-enhanced fully wireless earphones on its Zolo audio brand. Again, the promise here is to enhance sound quality. Enberion graphene photodetector is a big game changer. This is the first of its kind, as this detector is ultra-sensitive with an ultra-wide visible light detection, ranging from 400 to 1800 nanometers, which could not be achieved by silicon sensors alone. They would often be in part made with the InGas, which is an alloy made out of indium gallium arsenide, which is used due to its wide band gap properties, to which creates a longer wavelength cutoff. Due to its rare elements and complexity of fabrication, InGas sensors are usually expensive, while the Enberion graphene photodetector, by not requiring expensive elements, is said to reduce the final cost of the photodetector by about 30%. Volbak is a company that started back in 2015 by the brothers Nick and Steve Tidball, with the goal of using science to make the future of clothing happen faster, as it's stated in their website. In 2018, they introduced a jacket made with graphene, and they claim that it's capable of many things like conducting electricity and heat. It's waterproof and breathable, strong but not bulletproof yet. In theory, you would need more than 10 layers of graphene to stop a low-caliber bullet, but since there is no mention on what they were able to achieve, I would expect that they're not too far from reaching that. So maybe by 2020? If you'd like to get yourself one, you will need about $700, but make no mistake. This is only the first of its kind, and it won't take long for us to have a bulletproof jacket, since we are only a few layers away from achieving that. In summary, there are a lot of promising things in the world of graphene, and the message is clear. The next 5 years will be an exciting time for this technology, as we will see the rise of what was once thought impossible. All of the production problems that we know about are coming to an end. A single material will revolutionize all the industries in the world, and just like plastic, it will become part of our daily lives. This video was just to highlight the tip of the iceberg in terms of research and recent findings. So if you would like to get more videos like this, let me know in the comments, and don't forget to like and subscribe. Thank you for watching.